Hello everyone, this is Miss Chelsea and today we'll be learning about thermal energy and heat. Our standard for the day is S8P2D to plan and carry out investigations on the effects of heat transfer on molecular motion as it relates to the collision of atoms, conduction, through space, radiation, or in currents in a liquid or a gas, convection. To begin, let's talk about the kinetic theory of matter. The kinetic theory of matter states that the particles that make up all matter are constantly in motion. The state of matter the object is in will determine the speed and direction of the particles. For example, solids vibrate back and forth, while liquids move around more freely, sliding past one another, and gases move far apart at high speeds. Because particles move at various speeds, each particle has its own kinetic energy. The average kinetic energy of all particles can be measured. Temperature is what we call the average kinetic energy of the particles in an object. The more kinetic energy the particles of an object have, the higher the temperature will be. For example, if you pour hot coffee from a pot into a mug, the amounts of the coffee will be different, but the temperature will be the same because the average kinetic energy of the particles is the same. We commonly use three different temperature scales: Celsius, which is used most commonly throughout the world, and in this scale, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. Fahrenheit is what's used most commonly where we are in the United States, and in this scale, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. And finally, Kelvin is used most commonly by physicists. These units are called kelvins instead of degrees. In this scale, water freezes at 273 K and boils at 373 K. Temperature is always measured using a thermometer. This does not change when you change scales. Go ahead and pause the video and use what we've talked about to answer this checkpoint question. What happens when the kinetic energy of particles increases? So, now that we've talked about temperature, let's talk about thermal energy, or the total kinetic energy of all the particles that make up a substance. The amount of thermal energy a substance has depends on two things. First, the temperature. If you have two pots of boiling water that each have the same amount, the pot with the higher temperature will have more thermal energy. The second factor is the amount of the substance. The more particles that are in a substance at a given temperature, the greater the thermal energy will be. So, in our earlier example about having a pot of coffee versus a cup, the pot would have greater thermal energy, even though the two are at the same temperature. Here's another example. The orange juice in both containers is the same, but the orange juice in the pitcher has more thermal energy because there is more of the juice. Now let's try another checkpoint question using what we've learned. Would the water in a pond or the water in a full bathtub have more thermal energy? Why? Now that we've talked about thermal energy, let's introduce the concept of heat. Heat is the energy that is transferred between objects at different temperatures. Objects at a higher temperature will always transfer energy to objects at a lower temperature. Keep in mind that heat is measured in two different ways: calories or joules. So in the picture on the right, the energy from the soda will transfer to the ice because the soda has a higher temperature than the ice. So how are heat and thermal energy related? Well, when heat is added or removed from a substance, its temperature and thermal energy will be affected. Heat is not a property of a substance like thermal energy and temperature are, it's just a form of energy. So when two objects that are at different temperatures come into contact, energy will always be transferred. The object with the higher temperature will transfer its energy in the form of heat. to the object at a lower temperature until they both reach the same temperature. So heat is just a transfer of kinetic energy. So in the picture on the right, the energy from the cup will transfer to the woman's hands until they are the same temperature.